Black Holes and Cosmic Mysteries Introduction. Since the dawn of human history, we have looked up at the night sky in wonder. The stars, the galaxies, the endless darkness each has inspired myths, stories, and questions about our place in the cosmos. But among all the marvels of space, nothing captures the imagination quite like black holes. These mysterious giants defy the very laws of nature as we know them. They are invisible, yet they control the fate of stars and galaxies. They are born from death, yet they may hold clues to the very origin of the universe itself. In the heart of a black hole, our known physics collapses. Time slows down, space bends beyond recognition, and the boundary between reality and the unknown disappears. And black holes are only part of the story. The universe is filled with cosmic mysteries, phenomena we can barely begin to understand. What lies beyond the event horizon? Is our universe just one of many? What are dark matter and dark energy, the invisible forces shaping reality on the grandest scale? In this journey, we will explore the strange world of black holes and dive deep into the cosmic enigmas that continue to puzzle scientists and inspire dreamers. So, fasten your seatbelt for a voyage to the very edge of space and time, where science meets mystery, and the truth may be stranger than fiction. What are black holes at first glance? The term black hole might sound like science fiction, a bottomless pit in space, a cosmic monster devouring everything around it. But black holes are very real, and they are among the most fascinating objects ever discovered. A black hole is not an object in the usual sense. It's not a star, or a planet, or even a solid body. Instead, it is a region of space where gravity is so incredibly strong that nothing, not even light, can escape. That's why we call it a black hole. It is truly invisible, hidden from direct view. But how can something like this exist? The answer comes from one of the greatest scientific minds in history, Albert Einstein. In 1915, Einstein published his theory of general relativity, which changed our understanding of space and time forever. He showed that gravity isn't just a force pulling objects, it is the very bending and curving of space-time itself. And if enough mass is concentrated in a small region, space-time can bend so sharply that it forms a trap-a-hole from which nothing can get out. This is the birth of the concept we now call a black hole. At the center of every black hole lies what scientists call a singularity. This is a point where density becomes infinite, where all known laws of physics break down. Surrounding it is the event horizon, the invisible boundary that marks the point of no return. If you cross this horizon, there is no way back. Even if you traveled at the speed of light, escape would be impossible. Black holes come in different sizes. Some are small, formed from the collapse of massive stars, only a few times heavier than our sun. Others are monsters, the supermassive black holes that lurk at the center of galaxies, containing millions or even billions of solar masses. And in between, we may find mysterious intermediate black holes, though they are harder to detect. What makes black holes even more fascinating is that they are not just destructive. In fact, they play a key role in shaping the universe. They influence the birth of stars, control the motion of galaxies, and may even help regulate the balance of cosmic energy. So far from being just cosmic vacuum cleaners, black holes are central to the story of the universe itself. The birth of a black hole. To understand the birth of a black hole, we need to first look at the life of stars. Every star you see in the night sky, including our sun, is a gigantic nuclear furnace. Deep in its core, hydrogen atoms fuse together to form helium, releasing immense amounts of light and heat. This nuclear fusion pushes outward, balancing against gravity, which is always trying to pull the star inward. For millions or even billions of years, this delicate balance allows stars to shine, but nothing in the universe lives forever. When a massive star at least 20 to 30 times heavier than our sun runs out of fuel, fusion slows, and gravity begins to win the battle. The star's core collapses in on itself with unimaginable force. This collapse triggers a massive explosion known as a supernova, one of the most powerful events in the universe. What remains after the explosion depends on the size of the star's core. If the core is small, it may become a neutron star, a dense ball made entirely of neutrons. But if the core is massive enough, there is no stopping gravity. The collapse continues until the matter is crushed into a singularity, a point of infinite density. At that moment, a black hole is born. There are different kinds of black holes formed this way. Stellar mass black holes. These are the ones formed directly from massive stars, usually just a few to maybe dozens of times the mass of our sun. Intermediate black holes, rarer and harder to find. They may form when many stars and smaller black holes merge together, growing larger over time. Supermassive black holes, the true giants, millions or billions of times more massive than the sun. Almost every galaxy, including our own Milky Way, has one at its center. Ours is called Sagittarius A*, with a mass about 4 million suns packed into a region no bigger than our solar system. But here's the mystery. How do these supermassive black holes form? They are so huge that stellar collapse alone can't explain them. Some scientists think they grew slowly over billions of years, swallowing stars and gas. Others suspect they may have formed very early in the universe, from giant clouds of gas collapsing directly into black holes. What's certain is this: black holes are not rare monsters. They are natural products of the life cycle of stars. Where stars live and die, black holes are born, shaping the very structure of galaxies and influencing the cosmic web itself. The strange physics of black holes. Black holes are not just powerful, they are places where the very laws of physics bend in ways that almost defy imagination. To study them is to peek into the edge of reality itself. Let's begin with the event horizon, the invisible boundary of a black hole. Once you cross it, there is no escape. But what happens as you approach it? According to Einstein's theory of relativity, time itself begins to slow down. To an outside observer, it would look as though you are moving slower and slower, freezing in time at the edge of the event horizon. But from your own perspective, time feels normal. You wouldn't notice anything unusual as you fell. This effect, called time dilation, is not science fiction. It's a real consequence of how space and time are warped by gravity. Now imagine getting too close to a black hole. The pull of gravity is so much stronger on the part of your body nearer to the black hole than the part farther away, that it would stretch you out like a piece of spaghetti. Scientists call this dramatic process spaghetti. For small black holes, this would happen long before you reached the event horizon. For giant supermassive black holes, however, you could cross the horizon without feeling anything strange, at least until you got closer to the singularity, where the real drama begins. At the very heart of the black hole lies the singularity, a point of infinite density, where all the matter that fell in has been crushed into something smaller than a single atom. Here, our current laws of physics fail. Gravity becomes infinite, time and space lose meaning, and scientists are left with unanswered questions. Does the singularity really exist? Or is it hiding some deeper truth of the universe? One of the most astonishing ideas about black holes came from the physicist Stephen Hawking. In 1974, he proposed that black holes are not completely black after all, thanks to the strange world of quantum mechanics. Black holes can slowly leak tiny amounts of energy, what we now call Hawking radiation, over unimaginable timescales. This means black holes could eventually evaporate and disappear. This discovery connected the physics of the very large relativity with the physics of the very small quantum theory, hinting at a deeper, unified theory of the universe. And yet, mysteries remain. If black holes can evaporate, what happens to all the information that fell inside them? Does it vanish forever, breaking the laws of physics? Or is it somehow preserved, perhaps on the very surface of the event horizon, in a hologram-like pattern. This puzzle is known as the black hole information paradox, and solving it may unlock secrets about the fundamental nature of reality. In other words, black holes are not just cosmic monsters, they are laboratories of extreme physics, testing the very limits of human understanding. Observing the invisible black holes are, by definition, invisible. Since not even light can escape, we cannot simply look at them through a telescope the way we do with planets or stars. And yet, scientists have found ingenious ways to see the unseen, to detect and even photograph these mysterious objects. The first method is to look at their surroundings. When a black hole feeds on nearby gas and dust, this material doesn't fall straight in. Instead, it swirls around, forming a superheated accretion disk that glows with intense energy. As the material spirals inward at nearly the speed of light, it can release powerful X-rays, which telescopes in space can detect. This is how astronomers discovered Cygnus X1, the first strong black hole candidate, back in the 1960s. Another way to observe black holes is by studying their influence on nearby stars. If a star seems to orbit around an invisible companion with incredible speed, chances are it is dancing with a black hole. This is how astronomers confirmed the existence of Sagittarius A*, the supermassive black hole at the center of our Milky Way. By tracking the orbits of stars near the galactic core, scientists proved that millions of suns worth of mass must be packed into a region smaller than our solar system. But perhaps the most dramatic breakthrough came in 2015, when scientists detected gravitational waves for the very first time. These are ripples in space-time, predicted by Einstein a century earlier, caused by the collision of two black holes. When they merged, they sent out a burst of energy that shook the fabric of the universe itself, and we caught it here on Earth with instruments like LIGO. Since then, dozens of black hole mergers have been detected, allowing us to literally listen to black holes colliding across the cosmos. And then came the moment that made headlines worldwide in 2019, the Event Horizon Telescope project released the first ever image of a black hole, using a network of radio telescopes spread across the globe. Scientists captured the shadow of the supermassive black hole in galaxy M87, over 55 million light-years away. What we saw was a glowing ring of light surrounding a dark center, the silhouette of the event horizon itself. For the first time in human history, we looked at a black hole. Today, astronomers continue to push the limits. New telescopes in space and on Earth are being developed to peer deeper into the universe. The dream is to not only observe black holes more clearly, but to use them as windows into the unknown, to study the very nature of gravity, space, and time. Black holes and the universe's mysteries. Black holes are fascinating not only for what they are, but also for what they might reveal. They may hold the keys to some of the greatest mysteries of the cosmos. One of the most exciting ideas is the possibility that black holes could act as gateways. Some scientists speculate that instead of ending in a singularity, the core of a black hole might connect to another region of spacetime, creating what is known as a wormhole. If such passages exist, they could theoretically link distant parts of the universe or even different universes entirely. While we have no evidence yet, the idea of traveling through a black hole into another reality has inspired countless works of science, fiction, and fuels serious debate in physics. Today, another mystery is the connection between black holes and the early universe. Could the conditions shortly after the Big Bang have created tiny primordial black holes, smaller than mountains but incredibly dense? If they exist, they might help explain the puzzle of dark matter, the invisible substance that makes up most of the universe's mass, yet cannot be seen directly. Some researchers believe that swarms of these ancient black holes could be hiding in the vast darkness, influencing galaxies without us even realizing it. Then there is the enigma of dark energy, the mysterious force causing the universe to expand faster and faster. Some scientists wonder, could black holes be linked to this cosmic acceleration? Perhaps they are not just endpoints of stars, but engines of cosmic evolution on the largest scale. And of course, we face the greatest paradox of all, the information problem. If everything that falls into a black hole disappears forever, it seems to break the fundamental laws of physics, which say that information cannot be destroyed. Does this mean our understanding of physics is incomplete? Could black holes be hinting at a deeper, hidden layer of reality, a new theory that unites quantum mechanics and relativity into one? These questions remind us that black holes are not just objects to be studied, they are cosmic mysteries, clues scattered across the universe, urging us to rethink what we know. They may hold the answers to the origin of time, the structure of the cosmos, and even the fate of the universe itself. Cosmic mysteries beyond. Black holes may be the most dramatic mysteries in the cosmos, but they are far from the only ones. The universe is filled with enigmas that challenge our imagination and push the limits of science. Take neutron stars, for example. When a massive star collapses, but doesn't quite become a black hole, it forms an object so dense that a teaspoon of its material would weigh billions of tons. Some neutron stars spin rapidly, beaming powerful jets of radiation like cosmic lighthouses. We call these pulsars, and they're precise. Clock-like signals have even been suggested as tools for interstellar navigation. Then, there is the question of the origin of the universe itself. Just after the Big Bang, scientists believe the universe went through a period of cosmic inflation, expanding faster than the speed of light in a fraction of a second. But what triggered this sudden burst of growth? And why did it stop? We still don't fully understand. Another mind-bending mystery is the possibility of a multiverse. Could our universe be just one bubble in a vast cosmic ocean, each bubble with its own laws of physics? If so, black holes might not only trap matter and light, but could even serve as bridges to these other universes. The idea remains speculative, but it raises profound questions. Is our universe unique, or just one of countless realities? And then comes the question of the fate of the universe. Will everything continue expanding forever in a slow big freeze, where stars burn out and galaxies fade into darkness? Or will the universe tear itself apart in a violent big rip, driven by dark energy? Perhaps gravity could someday pull everything back together in a big crunch, collapsing the cosmos into a fiery rebirth. Each scenario paints a very different ending for the grand cosmic story. What ties all these mysteries together is a sense of wonder. For every question we answer, new ones emerge. The more we learn about stars, galaxies, dark matter, and black holes, the more we realize how much remains unknown. In many ways, we are still at the beginning of our cosmic journey, curious explorers, staring into the infinite night, searching for meaning in the vastness of space. Conclusion: as we bring our journey through black holes and cosmic mysteries to a close, let's pause to reflect on what we've uncovered. We began with the invisible giants of the cosmos, black holes. Born from the death of stars, they are the ultimate paradox, regions of destruction that may also hold the keys to creation. They bend space, stretch time, and test the very limits of human understanding. Around them, we see stars being torn apart, light twisted into rings of fire, and galaxies shaped by their immense gravitational pull. They are not simply monsters of the void, they are architects of the universe. But our exploration did not end there. We found that black holes are deeply connected to the biggest puzzles in science. Could they help us explain dark matter, the invisible mass that holds galaxies together? Might they be linked to dark energy, the mysterious force tearing the universe apart? Do they erase information forever, or do they hide the truth in ways we've yet to understand? These questions cut to the heart of physics and hint at a deeper, unified law of nature still waiting to be discovered. Beyond black holes, we touched the wider cosmic mysteries, the strange pulses of neutron stars, the explosive birth of the universe, and the possibility that we live in a multiverse, one universe among countless others. And we dared to ask the ultimate question: what will be the fate of everything? Will the cosmos freeze into silence, rip itself apart, or collapse back into fire and begin again? In the end, the greatest discovery is not just out there among the stars, but within ourselves. We are creatures of curiosity, born on a small planet, orbiting an ordinary star, yet capable of imagining infinity. For thousands of years, humanity has looked at the night sky and wondered, and in just the last century, we have built the tools to begin answering those questions. Every telescope, every experiment, every theory brings us closer to understanding the grand design of the universe. But the mysteries are not obstacles, they are invitations. Black holes and cosmic enigmas are reminders that our journey is only beginning, and the story of discovery is still unfolding. So the next time you gaze at the night sky, remember this: hidden in that darkness are secrets that could change everything we know. Somewhere out there, in the heart of a galaxy, a black hole spins, waiting to reveal its truth. Somewhere in the vast cosmic web, dark matter and dark energy shape reality in silence. And somewhere, perhaps, lies another universe, just beyond the reach of our imagination. Black holes and cosmic mysteries remind us of one powerful truth: the universe is not only bigger than we think, is more mysterious, more beautiful, and more extraordinary than we can possibly imagine.